we're going to be doing section, oops, there we go. We're going to be doing section 6.5, Law of Sines. Alright, so here, in general, and so now that we have the law, we're going to be using law of sines and cosines to determine triangles, given at least 3 parts of it. So in general, you can determine a triangle if you know 3 of its 6 parts, angles and sine, as long as at least 1 part's a side. If I only knew the angles, I wouldn't know the sizing of my triangle. So like an equilateral triangle always has 60 degrees, like 60 degrees for each of the things, but it can have a length of 1 or 5,000, we don't know. So here, let's go ahead and I'm going to draw the cases above. These first 2 we're going to do with law of sines. So we're going to do sine, and then we're going to do these for cosines, for law of cosine. Okay, so let's actually draw these cases. What do I mean by ASA and SSSAA? So here we have case 1. So in case 1, I know 2 angles and a side. Okay, so here if I know, and so in this case I might know this, and then I don't. So say I know, hold on, before I do all this, let's kind of define a default little triangle here. So we're going to have angle A, which deals with this angle, and the opposite side will be lowercase a for this side, okay? We'll have angle B here, which is this angle here, and then the opposite of that side will be lowercase b, and then angle C, so this angle right here, and then opposite would be lowercase c. The lowercase c is a little harder to tell the difference between. So the angle A, capital A, and the side across from it will be lowercase a, and the angle B, capital B, and the side across. And the reason we do this is because of just the way we set up law of sines. And so if we make this notation, this is what law of sines is. So in the first case, we're going to know 1 side and then 2 of the angles, or, so that's what it means, angle, side, angle, so angle, side, angle. The other one is I know a side and then 2 angles. So I'll know 1 side right here, like an angle here, and then, oops, I don't know the length of that side. But I know this angle here. And so if I know the angle, side, angle, or side, angle, angle, I can use law of sines to figure out what the rest of this triangle is. So this is case 1. Case 2 is I know 2 sides and an angle. So here I'll know a side, and then an angle. So I don't know what this angle is here, I don't know what this angle is here, but I do know what this angle is here. And so this is case 2. This gets a little bit more complicated. We'll get into it in a second. Because if I only know 1 angle, there may be 2 different triangles which exist, no triangles, but we'll deal with that. For case 3, I know 2 sides and the angle between them, so side, angle, side, so it'll be side, angle, side. And I don't know the other 2 angles of the 2 sides, but I can solve for it using that. And then also, for case 4, I know all 3 sides, but I have no clue what the angle is inside, right? And so once again, this is law of cosine. So in this section, would be law of sines. We're going to be doing case 1 and case 2. And section 6.6, we'll be doing case 3 and case 4. Alright, so let's draw, I already draw the ABC triangle. Let's draw it one more time just for good measure. So here we'll just draw a big triangle. Alright, so the A is this angle right here at this corner, and then little a is the side for the side opposite of that. This big C would be up here, this little c would be down here. The capital B right here, and then lowercase b here. And so this is how we default the triangle. So what does law of sine says? This law of sine says the ratio of this angle to this side is equal to the ratio of this angle to this side, which is equal to the ratio of this angle to this side. And when we have this, we can also write it upside down. Notice that this sine of A is equal to B sine of B, which is equal to C sine of C. So if the ratio is correct one way, it'll be correct the other way. All right? And since none of the sides are 0, and none of the angles should be 0, since these are triangles, and so they're non-zero entities, it doesn't matter if we flip it upside down. So this or this. So basically what the law of sine says, if I take the sine of the angle and the ratio of the side of the angle and the sine of the angle and the side which is opposite of that angle, that's going to be the same for each, and that ratio is the same for each in the triangle. Okay? So, what does that mean in practice? So let's actually solve ourselves a triangle. So let's pretend. And so what it means to solve a triangle, so to solve the triangle means find all the angles and all the sides, okay? So let's do this one step at a time. Here, what do I know? I know a side, I know an angle, side. And so angle, side would be, of course, or side, angle. Let's do it the other way. Side, angle. This is the same thing as angle, side. These are the same. So this is case 1. So we can solve this. Well, how would I even start to solve this? Well, the first thing I would start, so I want to find, so to solve this triangle, what am I looking for? I need angle B, and I need side little a and side little b, right? Because I know what C is, I know what angle C is, I know what angle A is. So these are the 3 things I'm looking for. The first thing I would grab would be angle B. Why? Because this one's really quite simple. A plus B plus C equals 180 degrees, right? Or pi, right? Or pi if it's in radians. Your book switches over to degrees, so we'll be using degrees for the notes. So if I know this, I know what this angle is right here. Well, it's 180 minus 25 minus 20, which gives me 135. 135, because this will be minus 45, and so 180 minus 45 gives us 135, so this angle right here is 135. And so I found the first thing I need to find, and that's in degrees. So 135 degrees. Alright, now that I have all the angles, I'm going to set up my ratio. And so here, let's set this up. So I know C and C, so I know these two, so we'll definitely use that. So the sine of C over C is equal to the sine of A over A. Okay, so do I know what some of this stuff is? Sure, right? So the sine of C, so this would be the sine of 25 degrees. 25 degrees over 80.4 is equal to the sine of 20 degrees. So sine of 20 degrees over A. We solve for A, and so solving for A means I multiply this across and then flip and multiply that. So I get 80.4, because that goes up top, times the sine of 20 degrees. Then I'm dividing by this, so it'll be the sine of 25 degrees. Okay, and then from here, you just crunch it through a calculator, and you're going to get that it is 65.1, roughly. As many as you want to carry. And let me put in that as rough. So that's a rough approximation of 65.1. Alright, we can do the exact same thing for B. So the sine of C over C equals the sine of B over B. We solve for B, and notice the only thing that's changing here is what I put in for the sine, and it solves the same way, so this would be 80. Actually, let me not skip that step. So here I'll have sine of 25 degrees over 0.84, as we had before. Here it will be the sine of B is 135 over B. That means B equals 80.4 times the sine of 135 degrees all over the sine of 25 degrees. And in this case, when you plug it in, make sure your calculator is set for degrees, not radians. You'll get completely wrong answers. And when you type it in if you type it in Wolfram Alpha or whatever you want as a computer algebra system, make sure you understand what it's inputting. Okay. Once I crunch through this, I roughly get 34.5, and so when I solve this triangle, I'm going to write A is equal to 65.1, and B is roughly equal to 134.5. Okay, and so now we've completely solved the triangle. We know all the angles, and we know all the sides. Alright, so that's what it means to solve a triangle. Alright, so we use this to solve word problems, right? The main point of this is to help us solve some word problems. And so let's do this. So we have a satellite orbiting Earth that passes directly over an observation in a satellite orbiting Earth passes directly overhead an observation station in Phoenix and in Los Angeles, 340 miles apart. At the instant the satellite is between these two stations, the elevation is simultaneously observed at Phoenix at 60, I should have a little degree symbol, and 75 at Los Angeles. How far is the satellite from Los Angeles? Okay, so let's put this all in. So I have me a little satellite right here. And I have a tiny little city here. I have another city here. I guess they're not that tiny. These are big cities. And we're going to call this one LA. We're going to call this one Phoenix. We know that this distance right here is 340. We know that this angle here is 75 degrees. We know that this angle here is 60 degrees. And so what do we want to find? We want to find the distance between, we want to find this right here. So we're going to just call this x. All right. Do we know what this angle is? Yes. So that's the first thing we're going to solve. We're going to take 180. We're going to minus 75 degrees minus 60 degrees. And that's going to give us 45 degrees. So we know this is 45 degrees. All right. So now we have this one and its opposite. So I know that the sine of 340, the sine of 45 degrees over 340 is equal to the ratio of anything else. Now if I want to find the distance between LA and the satellite, I need to use this angle here because it's the opposite. And if I was just going to arbitrarily, and I do mean arbitrarily, I can call this big C, big A, little a, and then big B, little b, right? And so here we're going to be doing the sine of C over C, and then we're going to do big B over this, and we know what that is at 60, so here will be sine of 60 degrees all over x. We solve for x, and so in this case will be x is equal to 340 times the sine of 60 degrees all over the sine of 45 degrees. And once we solve for that, we crunch it through a calculator. We get x is equal to the square root of 3 over square root of 2 times 340, which is approximately equal 41.6 miles, right? And so here we have that. And since this is a word problem, we should probably say, you probably should write out the satellite. If I could spell. Let's go back to if I could spell. Satellite is 416 miles from LA. Okay. And so here we can use the law of science to solve kind of real world problems. Alright, so let's look at the ambiguous case. So case 2, we have a little bit of trouble, right? In case 2, if we have side-side angle, there may be 2 triangles, maybe 1 triangle, maybe no triangles with the given properties. And so how do we know which one it is? Well, we kind of don't, right? So let me teach you a little symbol. So this means angle A, right? So this symbol means angle A. I'm going to have A and B. So let's just have this. So let's pretend we know angle A, and B. All right, so here I know some arbitrary angle A. So here we'll have dot, 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 and we have some arbitrary angle A. So we're going to call this A. I know this length here is B, and then across from it will be A. But notice if A is too small, I can't hit down to this line where the angle should be. And so if this is too small, there's no triangle. Okay. if it's if it ends up hitting exactly, there's a single triangle. So let's draw it again. Here of A, and here if I can hit this dotted line, remember this dotted line is the length I don't know. If this A hits it exactly, there'll be one triangle, and if the A overshoots it, the A angle here overshoots it. Nope, I need to make this a dotted line. Here I could have a triangle here or a triangle here, both with distance A, right? So notice here is my distance A, and so I can either hit this dotted line here or here. And then again, if I make it way big, so I didn't read myself my term, but let's go ahead and do it anyways. I have a dotted line here, I have my A, my angle A, I have my B, and if it's really, really, really large, right, A, and I can hit it over here, when I swing it over this way, I may not hit it, and so there'll be only one option. Now, how do you solve this? Well, it kind of comes out in the wash, and what do I mean by that? Well, I'll show you, okay? So here's what could happen, and so this is the ambiguous case, because if I know two sides of an angle, I may have no triangles which satisfy that whatsoever. I may have a singular triangle in this case, which is only one way to make it work. Either come straight down, that works, or A is so big, it only can touch it once. I can't actually touch it again. But in this case, it could be just in between being just right and over too big, and it has two different answers, right? Depending on the length of A. So let me show you a couple of examples of this. I'll show you an example of one where it works exactly, one where it doesn't work. I get two answers, and one where it doesn't work at all. And I'll help you to determine which one is which. Okay? So let's start. So here I have a solve an ABC triangle, right? Instead of giving you the triangle, okay, so I'm just going to redo this one. I started explaining, got through it, and then realized I could get some people lost. So let's start over. So let's draw this triangle. So here I'm going to have my angle A right here. I'm going to call that 45 degrees. And I know what the opposite side is, and so that is A is equal to 7 square root of 2. On this side, we're going to call this B. We're going to call this little b. We're going to call this big C and little c. And then we're going to call this big A. And so what are we looking for here? We're looking for angle B, angle C, and then side C. Let's see if I can just put a little curl. I'm going to put a little curl on the capital C, and we kind of differentiate it for the rest of this problem. Alright, so how do we start this? Well, if I didn't know what to do, the first thing I would look is say, here's the square root of 7 over 2. And here I have the opposite. So here I have a side and the angle opposite, or the angle and the side opposite. So that gives me my ratio that'll be constant across my triangle. I do know what B is. B is 7. So I know a side, and so I can solve for B. So let's do that. So here I'll have sine of 45, which is the sine of A over A, which is the square root of 2, equal to the sine of B, which I don't know, all over B, which is 7. So here, the ratio of in between it, we're going to solve for the sine of B. The sine of B equals to, oops, put in my B, equals to 7 times the sine of 45 degrees, all over 7 square root 2 over 2. So once we do this, do we know what sine of 45 degrees is? Yes, we shouldn't even have to type that in. You can still, of course, but you may hopefully memorize that. So this, the 7 cancels 7, square root 2 cancels 2, and I get 1/2. Alright. So sine of B is equal to 1/2. Now notice that sine of B equals 1/2 twice in between 0 and 180. The first one is if you just type in the arc sine here. If I type in the arc sine B, I'm going to get arc sine of, oops, the arc sine of 1/2, which gives me B. That's going to give me 30 degrees. But notice there's also another option. The other option here is 150 degrees, also gave me 150 degrees gives me the same thing here. And notice, so let me draw this up here a little bit. Let me draw this up here. So here we have our unit circle. So whatever angle I get here, this angle here, this angle here will also produce the same little mini triangle and give me the same value for sine. How do I find that? I just take 180 minus whatever this angle is, so we'll just call this alpha, right? Alpha. And that'll give me this angle, I'll just say beta, right? This angle here, beta. And so your inverse sine should give you two options every time. In this option, 30 degrees makes sense because 150 plus 45 is over 180, right? So 150 plus 45 is greater than 180 degrees. So that doesn't make a triangle. So this is the only one that makes a triangle. So we know that b equals to 30 degrees is the only triangle that we have. Okay? Alright, so now that we know two angles, we can figure out the third. So C, so we know this has to be 30 degrees. So we know that C now can is 180 minus 45 minus 30, and that's equal to 105. And so if I put 105 right here, I now have all my angles 105 degrees. And then I can use the law of sines to finish this off. So here, the law of sines, it'll look the same thing as this, just we don't know the angle. Oh no, this time it'll look different. So let's just go ahead and use this. So sine of 45 degrees over 7 square root 2 equals the sine of C. This case is going to be 105 degrees all over little c. And so we can solve for little c. Little c equals let me crunch through this. Little c equals, that goes up, so c, oops, hold on, this goes here, so 7 square root 2, and this comes down, so sine of 105, right, degrees, all over sine of 45, oops, 45 degrees. You crunch this through a calculator, and then you can get that this is roughly equal to 113.5 degrees. Okay, so this is 13, or not 13, but 13.5 units. Whatever our units are here, it's 13.5 of it roughly. Okay, so we solved this triangle. So once again, how to do these is you look for which ratio you know of an angle and the side opposite, and then you figure out what other data point you have, and then you just fill out that from here. Once you, in this ambiguous case, once you get the other angle, just make sure when you do the inverse to find the angle, check the other angle to see if it works. In this case, it was just too big, right? It wouldn't make a real triangle because that one, and if this was 150, it'd be too big to make another triangle. So we know it's this one. I'll show you a case where it's not too big in the next one right now, and we'll see how it works. And I'll show you the last case where it's just way too big. The length's way too, and it doesn't work at all. Okay, so let's do that. Let me show those very clearly right here. So in these two triangles, so here we have another triangle, and here we just have crazy numbers, right? Because this is what your book's going to give you. Let's be honest, right? All right, so here I have this to be 43.1 degrees. So we have to use a calculator at this point. And I have A equal to 168.2. I'm going to have B equal to 248.6. This is my A here. This is my C. I'm going to make this a cursive C, and then little c here. And then this is B here. And so once again, we're looking for capital B, or the angle B, the angle C, and the length C. All right, so let's do this slowly. So the first, we're going to do the same thing. We have this ratio and sine of B, so we're going to solve for that first. And so we're just going to jump right into it. So sine of B is equal to over little b, which is 248.6, equals to the sine of A, which is 43.1, all over B, or the length, which is 0.2. Here we're going to solve for it, and so we get the sine of b is equal to, we just multiply, so it would be 248.6 times the sine of 43.1 divided by 180.86.2, and this will give us approximately 0.9122. Now let's take the inverse of that. So the inverse of, or the arcsine of 0.9122, well, that gives me what? Well, that gives me roughly 65 degrees. So 65.8 degrees. But notice here, if I take 180 minus 65.8 degrees, I'm going to get 104.2 degrees. And so this is the other angle. Once again, here when we take the arcsine gives us values here. But notice we could have, for a triangle, we can have values here, anywhere between 0 and 180, not including those numbers, right? And so the first angle it gave us here was about 65, but the other angle, it would be 180 minus that, will give us this angle here, which is 142. But notice that 114.2 plus 43.1, well, that's less than 180. And so this makes another valid triangle. So I don't know if it's this one or this one. That's why it's called the ambiguous case. So let's go ahead and split it from here. So here we have, so here we'll have B, and so now instead of just having one set of values, we're going to have two sets of values. So let's rewrite that. I mean, you could leave it up there on the notes, that's fine. So C, and then we're going to have another B, C, and then C. And so in this case, B is going to be 65.8 degrees. And here, in this case, B is going to be 114.2 degrees, because both of these are valid. Once we have these two, we can solve for C. And in this case, C is approximately, so 180 minus this and this will approximately give us 71.1 degrees. Okay, so 180 minus the 43.1 minus the 65.8 gives us approximately 71.1 degrees. And with that information, I can solve for C. And here, 182. 186.2 times sine of 71.1 degrees all over the sine of 43.1 is equal to 257.8. Okay, so we just plug that in, 7.8. Now, where did I get this from? Well, this would just be here if I just solve this again. For C, right? So you can solve for this. Let me actually give you that step real quick. I was worried about space. So here I have the sine of C, which I know, which is 71.1 all over little c, which is equal to the sine of 43.1 all over 186.2. I solve for C, I'm going to get this, okay? Because that goes up top, that goes on the bottom. I get this, and I solve for it, and I get this triangle. So here's one of the triangles. Here, if I redid this triangle, so this triangle, I'm going to find C. Well, the cursive C here would be is equal to 180 minus 114.2, because that's now my B for this one, minus the 43.1. I get roughly 22.7. Okay, so it just equals 22.7, and then this will be the same here. Instead of the 71.1, we'll be typing in the 22.7. So here will be C equals to 186. And once again, we can solve for it this way. Sine of 71. Oops, no, that's the one we're swapping out. We're swapping out this for this, because that's our new C. And we divide by the sine of 43.1. We crunch through that number, and we get approximately 0.5 2. Okay, and so in this case, there were two possible triangles. That's why it's called the ambiguous case. And so here I have this, we have this. And so these take a little while. So when you work through the homework, crunch through these. For those doing the flipped classroom, if you have problems with these, we'll talk about, we can do some more in the flipped classroom. For those doing the online version of this class, that's what the discussion board for. So use the discussion to talk to each other, and the flipped classroom also has a discussion board. So currently. So please use that, and please use that as a resource. So give these a try. The last one is sometimes we don't form a triangle, and let's show that, right? So here I have A here is 42. I have capital A is 42. Lowercase a is 70. B is 100. 122. And I don't know angle B. I don't know angle C. Cursive, and then we don't know little c. To solve this triangle, I need B. I need the angle B, I need the angle C, and side C. But notice what happens when I first start to solve this. So let's find sine of B, right? So a sine of B over 122 is equal to the sine of A, which is 42, all over A, which is 70. That means, and so if I solve for B, sine of B is equal to 122 times the sine of 42 divided by 70. Well, that equals 1.17. But notice, there is no such sine of B, which is going to give me something over 1, right? Or B of the arc sine of 1.17, as you guys did in the earlier section. This is outside of its domain, right? I can't plug this in, this inverse sine. And so this is equal to undefined. What does that really mean? There's no triangle. There's no such triangle. There's no such triangle here. So there's no such triangle, and so we've shown each of the cases. So in this case where we know an angle and a side, it can have no such triangle, as we've shown here. There could be two possible ways to build this triangle, as we've shown here. Or, as we go back to this one, there's only one way to show a triangle, because this angle gets too big, and yet I can still form a triangle from that. To determine if there's a second triangle, just find the other angle, which is allowed. So remember here, inverse sine will give you stuff in between here, but the angle allowed for triangles is here. So take 180 minus that and see if it still forms a triangle. In this case, yes, because this is less than 180, so if I add these two up, it's less than 180, which gives me room for C not to be negative. And in this case, no, it was over 180, so if I had a triangle that had it to be 150, that's just too big, and I'd have a negative angle, which isn't true for a triangle. So that's the end of these notes. Good luck with everything, and we'll call this one good.